Hi guys, tonight we are going to take a look at using the graphing calculator to graph quadratic functions. So there are two sheets to tonight's notes. One is the graphing calculator reference sheet, which you see before you, and the other one is the notes sheet. And they're two separate sheets of paper. So we're going to graph this function here, y equals x squared minus 4x minus 12. And we're going to use the calculator to help us find the minimum or maximum, the vertex, the x-intercepts, and the y-intercept. Although the y-intercept is easy to see from the equation because it's right here, it's minus 12. So turn your calculator on, and in your y equals button, we are going to put the function x squared minus 4x minus 12. If we hit graph, we don't see the vertex or the y-intercept, but we do see the x-intercepts. So we need to adjust our window to see the entire function. So I'm just going to go off of my y-intercept here, which is negative 12. So I want to pick a number that is below or smaller than negative 12. So I'm going to hit the window button, and then I'm going to go down here to my y minimum, and I'm going to change that to negative 17. And if that doesn't work, I can just go back to the window again. But I want to be able to see the y-intercept, the vertex, and I also want to see the x-intercept. So now if I hit graph, I can see my vertex is right here. I can see my y-intercept, and I can see my x-intercepts. So the first thing we want to do in step 3 is find the minimum or the maximum. And since this parabola is opening upward, we are looking for a minimum. So we're going to hit second and trace, and we're going to hit number 3 because we're looking for a minimum. And right now, the calculator is asking me, is this my left-bound curve? So right now, I'm on the y-intercept, so I'm just going to move a little bit over there. So I know my vertex is right here. I'm to the left of the vertex. That's why this says left-bound. So I'm going to hit, yep, that's what I want. Then I need to move my cursor to the right of the vertex. So my right bound, and I hit enter because that's what I want. And now I'm asking the calculator to take a guess as to where the vertex is, and the calculator is picking 2 and negative 16. I know it's kind of hard to see because the cursor is there. So our vertex is at 2, negative 16. This also tells us what our axis of symmetry is because that is the x value of the vertex. So now we want to find the zeros. What if the x-intercepts aren't easy to see or aren't integers? How can we use the calculator to help us do that? So I'm going to go to second and trace again. And this time I want to find the zeros, and so that's number 2, and I'm going to hit enter. So I have 2 zeros. I have one to the left of the y-axis and one to the right of the y-axis. So I'm going to do this one first. So I need to get above the x-intercept. So that's my left bound. Then I need to get below the x-intercept. That's my right bound. And then again, the calculator is going to take a guess, hit enter, and I have 1, 0, 1 x-intercept, 1 solution at negative 2 and 0. I need to redo that with the other x-intercept. So I apologize, but you're going to hear a lot of clicking. So second and trace again. I'm looking at my zeros. So now I need to get to left bound. So underneath this x-intercept, so I need to click my right arrow till I'm as close to it as I can get. So now I'm underneath it. I'm going to hit enter. My right bound, I need to be above it. I'm going to hit enter. Hit enter again. And my other zero, my other x-intercept is at 6, 0. So my calculator will not do step 5, but the y-intercept you can get from the equation. And if you do hit the trace button before you do steps 3 or 4, it'll automatically give you the y-intercept of the function. So that's how you find the minimum or the maximum, and how you find the zeros or the x-intercepts. And this is especially helpful when these numbers are not integers. Okay, so now you need your second notes sheet, and it should say Unit 5-13-1 Graphing Quadratics with Calculator Video Notes. And we are going to define and redefine these 8 vocabulary terms.
Okay, we're going to use what we know to help us do an example on the notes. But before we do that, I want to just go over some vocabulary, some of which we know already and some of which might be a little bit new to us. So the first one I want to go over is domain. The domain of a function are the x values of the function. And for quadratic functions, that domain is always all real numbers. Okay, next we want to take a look at the range of a function. So if the domain is the x value, the range is the y values of the function. Okay, next is the vertex. And the vertex is the highest or lowest point of a parabola, and this is what we use to refer to as the minimum and the maximum. Okay, if you remember about the axis of symmetry, the axis of symmetry is the line that divides a parabola evenly in half, and that is always written in an x equals equation. Okay, we know what the x and the y-intercepts are. The x-intercept is the point where the graph passes the x-axis, and the y-intercept is the point where the graph passes through the y-axis. And sometimes x-intercepts, we can have 1, 0, or 2, and y-intercepts we're always going to have 1. Okay, so the last two terms on our vocabulary list are the increasing and the decreasing interval. And this will be a little more clear when I show you the graph, but the increasing interval is just where the graph is increasing or going uphill when we're looking at the graph from left to right. The decreasing interval is where the line is going down, or the line is decreasing when we're looking at the graph from left to right. Okay, so now that we have the vocabulary, we're going to take a look at how to interpret all this from a graph of a quadratic function. So we're going to look at this example right here, y equals x squared plus 2x minus 3. The domain in all quadratic functions is all real numbers, and that's the symbol for real numbers. It's just an R with 2 lines from it, so it's all real numbers. So any number will work in this quadratic. So we have to graph this to determine what the range is, what the vertex is, what the axis of symmetry is. So we're going to start with the y-intercept because we can get that from the graph, and the y-intercept is right here, and it's negative 3. We need to factor this to find the x-intercepts. So if we do that, the factor pairs of negative 3 that add up to 2 are x plus 3 and x minus 1. So this means that our x-intercepts, there's going to be 2 of them. If x plus 3 equals 0, then x has to equal negative 3. And if x minus 1 equals 0, then x has to equal positive 1. So our x-intercepts are at negative 3 and at positive 1. So I'm going to write those right here. We have an x-intercept at negative 3 and an x-intercept at positive 1. And our y-intercept, we said, was negative 3. So looking at the a value, or the value of x squared here, it's positive. That means that our parabola is going to open upward, and it is going to have a minimum. So now we have to find the axis of symmetry, the range, the vertex, and what parts of this interval are increasing and decreasing. So we talked about finding the axis of symmetry. The formula for that was the opposite of b over 2a. So if we look at our coefficient of a, that's 1. Our coefficient for x squared is 1. Our coefficient for x is 2. And we don't need the c, so we are just going to plug this in. It's the opposite of b, so it's negative 2 over 2 times 1. And that's going to give us an axis of symmetry at x equals negative 1. So our axis of symmetry is going to be in here, which is the halfway point between negative 3 and positive 1. So we can use that axis of symmetry for the x value of our vertex. So the x value of our vertex is negative 1. To find the y value, I just take my equation, y equals x squared plus 2x minus 3, and I plug in negative 1. So negative 1 squared plus 2 times negative 1 minus 3, if I do that whole little happy dance. And so that gives us a y value of negative 4. So my vertex is negative 1, negative 4. And so my vertex is right here. So we now know that that is the turning point of the parabola. So we can go ahead and graph that parabola in there. Here's our turning point, and it comes back up. So there's our parabola. It has a minimum because it's opening upward. Here are our X-intercept and our Y-intercept. So how do we determine the range of this function? So since it's a minimum, here is the minimum value. My y-axis doesn't go any further than -4. So our range is always going to be a y, because our range measures the y values of the function. And in this case, everything is above -4. So my lowest point on my y-axis is -4. So it includes everything including -4 and everything above it. So my range is y is greater than or equal to -4 because it includes -3, -2, -1, 1, 2, 3, 4. So y is greater than -4. This number here and this number here are always going to be the same, just like the x value of the vertex and the axis of symmetry are the same. So now we're going to take a look at our increasing and decreasing intervals, and they're always written as an inequality with x. So if I'm looking at my graph from left to right, and I start with my parabola here, this is the area where the parabola is going down. And then the axis of symmetry and the vertex, that is the halfway point. So this is the turning point, so this is where my parabola is going up. So here's the down, and the down is from all the way over here, which is infinite, to it starts the turning point at -1. So my decreasing interval is every number that is less than -1 on the x-axis, and we're not going to include -1 because that's the turning point. And then that turning point brings us to the increasing part of the interval, and that is everything that is greater than -1. So x is greater than -1 is my increasing interval. So that's it for the notes. There's no Google form tonight. We are going to practice in class on Monday with this working math. We'll have examples of this to go over together as a class and to go over individually.